Okay, so our third transformation is a rotation. So a rotation is a transformation in which a figure is turned about a fixed point called the center of rotation. So rays drawn from the center of rotation to a point and its image form the angle of rotation. Rotations can be clockwise or counterclockwise. However, we will always be doing counterclockwise rotations unless told otherwise. And then a rotation is in fact a rigid motion. So a rotation through point P through an angle of x degrees will map every point Q in the plane to a point Q prime. So if we have Q not being the center of rotation, then of rotation P, then QP would equal Q prime P. So these guys would be equal. And the measure of angle QP Q prime would equal x degrees. So if this here is x degrees, then the measure that's formed here is equal to that. And then if Q is the center of rotation P, then Q would be equal to Q prime. So if we're rotating something counterclockwise about the origin, all of the following are true. If I rotate this 90 degrees from AB, I'm going to be moving it to negative BA. So if this guy is here at 2, 4, a 90-degree rotation would be at negative 4, 2. So this would be at negative 4, 2. So you can see here, if I connect these to the origin, I have formed a 90-degree angle there. If I'm going 180, I'm taking 2, 4 and moving it all the way down here. So that would be at negative A, negative B. So negative 2 down to negative 4. So as you can see, if I continue to draw that line out, you have a straight line at negative 2, negative 4. And then if I want to go all the way from 2, 4 down 240 degrees, we're going to be going to B, negative A. So I'd be taking this guy, and instead of going all the way over here, we're at B, which would be at 4, and then negative 2. So this would be at 4, negative 2. And if you connect it to the center, you see that it's actually only 90 more degrees until we get back to our original space. So if you want to play around with this, you have two graphs here that you can use to manipulate and move around. The last thing we're looking at is identifying rotational symmetry. So a figure will have rotational symmetry when the figure can be mapped onto itself by a rotation of 180 degrees or less about the center of the figure, and that point would be called the center of symmetry. So note that this rotation can be clockwise or counterclockwise. So for example, this has rotational symmetry because we have it of 90 or 180 degrees. So if I take this figure and if I go 90 degrees, it maps right back onto itself. It's now moved to here, then 180 is back to here. But notice that 45 degrees of a rotation does not. This is exactly at 90 or 180 for this to have rotational symmetry.